Hello, everyone. Welcome to another exciting episode of the GeoTrip podcast. And today I'm very excited because we have senior environmental scientist Dominica Mvorn, Dr. Byron Winston. And I just want to do a special shout out before I even sing his accolades because Byron's one of the reasons that myself and many other Caribbean students actually made our way to University of Arkansas. He's been a stalwart there, and he's also been serving and giving back to the community while advancing himself professionally. And so currently he is a member of AECOM, where he's doing some amazing things that he's going to tell us about today, and just kind of share how he analyzes and synthesizes data to drive critical decisions and achieve various objectives as we move forth as scientists. So just wrapping it up, water quality scientists, environmental policy development, and everything in between. Byron, welcome.
Thank you very much for having me on. I've listened to several of the episodes, and I must say that every time I do, I am educated. I thought I knew a lot, but just listening to the breadth and the scope of research and ideas that are expressed on the podcast, I get educated every time. So thank you for having me on this episode.
And thank you for being here and to adding to that wealth of knowledge that our previous guests have opened us up to. So, Byron, you are from Dominica. It's always nice to have another person from the Caribbean on. And for those of you who don't know, Dominica is known as the nature island. So my question for you is, how much did being from Dominica, growing up there, influence your decision to become a geoscientist?
Well, it is probably the number one reason that influence that kind of led to me being a geoscientist. I remember growing up in Dominica, I was always fascinated by the different types of soils and the different types of rocks that I saw, along the shoreline. We have areas that are volcanic. We have areas where you see some type riverine sediments. We have areas where it looks, mostly red. The soil is red, and I was always interested in that. There was a pivotal moment where I solidified that I wanted to go into geosciences. I was probably maybe age 12, and there was an area in Dominica where we would go swimming every Sunday after church. That is, right? Growing up in the Caribbean, you had to go to church first, and then after church on a Sunday morning, if you grew up Catholic, you could do anything else that you wanted. So there was an area we used to go swimming in, a river. And that particular hole in the river or the pond, whatever, was about 20 feet deep, about 20 feet wide. It just made for an excellent swimming area. And there was some development that occurred in that area, and they pretty much pushed all the material into the river. So what was once a very deep swimming hole was now like about 5 feet deep and maybe about 5 feet wide from all the sediment and dirt that they pushed in there. And I remember asking my dad, I said, how can they do that? Aren't there any laws to prevent that? And he said, yes, they are, but they are not enforced. So, and also what happened was after a while, a lot of plants started taking over the riverbed and the floodplain. And I saw that and I was like, wow, I would really like to understand sort of the processes that occur, when you have something like that happen. At that point, I did not know it was geosciences, right? I did not know there was a field called geosciences. So over time, just, going through high school and learning more about the chemistry, the biology, the hydro, I figured out that, okay, I'm going to go into environmental sciences. And then when I went into environmental sciences, it was so much connected with the geosciences. It just became natural that I just naturally fell in love with geosciences.
Oh, wow. Thank you for really taking us on that journey. So you've fallen in love with geosciences, and we're going to jump a little bit just with time in mind. You fall in love with geosciences, and you went straight through and completed a doctorate. And then you kind of went on to some postdoc research. Do you mind talking a little bit about that for us? Because that was some exciting research that I think kind of really paved the way for where you are now.
So, you want to talk about the postdoc research or research during the doctorate as well? Because it all kind of led to, one thing led into another, which led into another. And it's interesting how things just came to be. So at the University of Arkansas, where I did my master's and my PhD and my postdoc work too. When I got there, I was really interested in doing environmental chemistry, but with an emphasis on water. And again, growing up in Dominica, I was surrounded by water, so it was just kind of natural. And I found a project over in the biology department where they were looking at groundwater contamination from fertilizer application. And I wanted to understand how that worked, the biogeochemistry, basically looking like how the fertilizer, the nitrates from the fertilizer made it through the soil profile, made it through the rock, made it through and ended up back into the streams, which was causing a lot of water contamination. So I did a master's looking at the biogeochemical transformation of nitrogen and phosphorus and stuff like that. Pretty much what contaminated the water and how we're going to clean it up. And then after I did that, I decided to go into looking at drinking water because they were having issues with drinking water and how the drinking water was being contaminated by algae. So I did a PhD looking at that as well. And just fascinating. I fell in love again with the geosciences, the geochemistry, the way how everything worked together, how the biology influenced the chemistry, how the chemistry influenced the geology, and vice versa. And I started doing that. So that led into my postdoc. Now in my postdoc, I studied how climate change was impacting the drinking water reservoir through the contamination caused by the nitrogen and the phosphorus and the growth of the algae. Basically, everything I did led me to the point I am now. But before that, I ended up working for the oil and gas industry, looking at contamination of groundwater by hydrocarbons. And I was able to do that because of the knowledge and experience that I got during my master's degree, where I really got a really good education in hydrogeology and groundwater geochemistry. So that it was like a big circle. Everything kind of came back to that when I started working in the oil and gas industry. And it was actually a professor, Dr. Walt Manger, you might remember him, Liga, who actually helped me get that position in the oil and gas industry, even if I did not have a pure geology degree, like most of the other people who worked in the industry. So then while I'm in Houston working oil and gas industry, cleaning up contaminated sites from, hydrocarbon impacted oil and gas activity, I started sort of venturing back into the water quality side of things. And I joined the team here in Tampa, the algae harvesting team here in Tampa, cleaning up contaminated sites with algae. So my surface water experience and knowledge from my PhD and postdoc kind of brought me back to the surface water quality side of things. So everything was connected. And now we're taking some of the algae that we're harvesting when we're cleaning up those lakes, and we're converting that to biocrude. So it's just an amazing circle of how the education that I received at the University of Arkansas, throughout my degree, postdoc, PhD, etc., is all connected, and it comes right back full circle.
I mean, truly amazing, Byron. And thank you. You answered that question perfectly because I wanted you to show how, with the breadth and scope of knowledge you had, you were able to literally serve in cross-functional roles amongst various disciplines. And also, of course, I remember Dr. Manger. Special shout out to Dr. Manger, Dr. Van Brahana, Dr. Doy Zachary, faculty members who really invest in the students and really show why it's good to have faculty who take a vested interest and actually help or recommend you speak your name in rooms that you don't necessarily get into. So aside from mentorship, you do experience sponsorship, and that's a whole conversation for another day. So we'll get back to the technical, but I just really wanted to comment on that.
That's a pretty interesting pathway that you had there. It sounds like you were really fortunate to see kind of both sides of that coin, working both on the industry side and more of the kind of remediation side as well. So for our listeners, what would you say are some of the biggest threats to freshwater quality?
That's an interesting question. Human activity. And I say that because a lot of the things that we do and we depend on just for our everyday living can be and possesses a threat. So our agricultural activity can impact both groundwater and surface water negatively. In that, when you have runoff goes straight into your surface water system. You have your pesticides, your nutrients go into the surface water system. Similarly, when you have groundwater infiltration, you have infiltration into the groundwater and into the aquifers, you can have contamination that way as well. We have oil and gas pipeline breaks. Sometimes you have septic systems that leaching materials into the groundwater. And now climate change is playing a very important part in terms of impacting water resources, because you have extreme drought in certain areas, which concentrates pollutants and contaminants. In some areas, you have excess rainfalls, which, causes more runoff and contributes to contamination of surface water. When we had Hurricane Ian here in Florida not too long ago, a lot of the wastewater treatment plants, they were just completely overrun. A lot of the sewer system was overrun, so you essentially had, raw water, raw sewage being spilled out into the streets, which eventually mix it into your lakes or to your estuaries or to your bays. So I would say human activity and everything that's associated with being human contributes to deterioration of our water quality.
Totally agree, Byron. And before I actually switch gears a little bit, I'm just going to ask you if you can, using AGU plain language approach, can you explain for our audience members what are aquifers and also just a basic description of the groundwater cycle?
Okay, in very plain language, an aquifer is essentially a storage container for your water. And you have rainfall, water infiltrates into the soil, it gets down into the groundwater system, and water will come back to the surface either through upwelling in certain areas, or it makes it out to a lake or to the ocean. You have sunlight, which causes evaporation. You have your cloud condensing, moving inland, again getting saturated, dropping water, so the cycle continues. That's as plain as I can give it. I might have missed a few things in there, but that's as plain as I can give it. Hopefully that works.
No. We definitely appreciate that general overview. And I just kind of wanted to make sure we kind of touched on what we meant by when we were talking about aquifers and groundwater as we take this conversation forward, because part of some of the work that you've done for your research and with your career has really led you to design experimentation, conduct evaluations, and really start thinking about how groundwater contamination, etc., and the impact of climate change to algae and groundwater. And so I'd really love if we could touch on that for our audience a little bit. Like, what does that entail? What exactly does, a project look like for you?
It depends, So if I'm doing a project well, when I was working in the oil and gas industry, mostly things, for example, you would be driving by a cliffside and you'd see, crude coming out from the cliffside, and you'd be like, okay, that's interesting. This should not be coming from there. So an experimental, the objective would be trying to figure out, well, where is this thing coming from? Most likely it's coming from a pipeline. So your job would be to try to identify, first thing you try to do is identify, the pipeline. Physically locate the pipeline. Then secondly, what we would do, we'd collect some samples of that material and send it for geochemical fingerprinting, which kind of identifies and tell you exactly what it is in terms of the crude material. Is it like, is it a crude that came from Texas? Is it a crude that came from Venezuela? Is it a crude that came from, the Middle East? Those things can help you because then you would know, which pipeline is going to. Other projects you have, the client would call and say, hey, we have some contamination of our groundwater. We're finding benzene or something like that in our groundwater. So then you would go in and put in water wells, drill wells, collect soil samples, collect water samples, and send this to the lab and do some analysis to figure out, what the concentrations are, what exactly is it, and then we kind of trace it back to, to the source. So everything we're doing is trying to trace it back to the source of the contaminant. For the algae projects, it's similar. We collect water samples. We look at the algae that's growing in there, and we check to see if they're producing any toxins. And then we go back and look at the watershed, which is basically the area that drains into the lake or the pond, and try to pinpoint what activities in there that are causing this algae to grow out of control. And then when we find that, we come up with some management type of approaches. Sometimes it's very simple as maybe storing your fertilizer properly, or you might need to go in and put in some type of barrier that contains media like sand and gravel, or carbon, charcoal, activated carbon. Sometimes the solutions are very, very straightforward and very simple. Other times it's much more complex because you have a lot of different sources. It might be septic systems. It might be agricultural runoff. It might be coming from a wastewater treatment plant. It might be coming from people's lawns. So depending on what the source or the sources are, you have to come up with a different remediation, a different remedies to fix the problem.
I like that statement that you made earlier when I asked about kind of what are the biggest threats to like water quality. And you mentioned that it's a human problem, right? Like we are the threats. How do you see climate change impacting that situation?
Oh, climate change is going to have it's already having a tremendous impact on our freshwater resources. If you look out west, they are in severe drought. There are lakes that have lost, 50% of the water capacity that they had maybe 25, 30, 40 years ago. There are places, you don't even need to go that far west. Even in Texas, there are places that were in severe drought a few years ago. They had some rains and that helped with that a couple of years ago, but there are places in Texas where they have not had significant rain since last July. So, climate change is going to have a tremendous impact on water resource availability. And in addition to that, the extreme drought that some places experience, again, is going to make conditions very, very favorable for harmful and toxic algae to grow. Toxic algae, we call them cyanobacteria. They love warm temperatures, warm water. You give them warm water, they're good to go. So you give them warm water, which causes the water column to be very stable, which they like. You give them the nutrients that's coming from our human activity, and you're pretty much creating the absolute perfect conditions for cyanobacteria, the toxic cyanobacteria to grow and to contaminate our water, make our water unusable. And there are many examples of that occurring. There are places in Ohio where they had to completely shut down their water treatment plant because it contained toxins. Every year you might hear of pets getting killed after they've gone into lakes that have been impacted with cyanobacteria and toxins and stuff like that. So climate change is going to play, and is already playing, a tremendous role on our water resources. I mean, I don't want to scare everyone and, make everyone, completely frightened, but it is serious. Unfortunately, we have a lot of people who are working day and night to ensure that our water resources are safe. But, it is challenging, and the challenge is going to continue. So, we have to continually try to come up with innovative ways to deal with those issues.
Wow, I'm so glad you brought that up, because one of the things we like to do at the GeoTrip, aside from talking about the science or the geoscience that we traditionally don't see or really know what's happening behind the curtain, we like to tie it back to real life. And isn't a classic example of these changes and the warming of the water column and seeing giant blooms? That's kind of what's happening with the oceans, right? Where we're seeing like tons and tons of the brown seaweed that
Yes.
every year is coming more and more frequently and more denser. So like sometimes you can't even go to the beaches, like in Mexico, the Caribbean.
Yeah, sargassum, I mean, it is a direct consequence of nutrients and a warming ocean. They call it the Great Sargasso Belt because it started over in the Sargasso Sea. And I mean, it is devastated the Caribbean and Mexico. And it ends up on the beaches. And as you guys know, I mean, the economy of the Caribbean is very much tied to the ability to go to the beach. So, if you can go to the beach, I mean, you have lost a significant portion of your GDP right there. And in addition to that, there are also health risks associated with the sargassum, because when it gets pushed onto the shore and it deteriorates, it starts releasing hydrogen sulfide. And, hydrogen sulfide can be very potent and very toxic to humans, not just as an irritant, but can actually cause some severe medical conditions. So climate change, water quality, it goes, like you're saying, it goes far beyond just the science. You have lives that are impacted from an economical and financial standpoint, but also from a health risk and medical standpoint as well.
I know you said that you didn't want to scare anyone, but I think we have to find that balance, because for a lot of people, they hear climate change and usually the first thing that comes to mind is, yeah, it's going to be warmer, but I can deal with 1 or 2 degrees, warmer climate. But we don't really have a full appreciation for the myriad ways that climate change is already affecting all of us, right? So going back to those toxic cyanobacteria, I think you mentioned, is that just a threat for surface water, or could our groundwater be polluted as well?
Yeah, I mean, that's a really good question, because there are some studies that are finding that in lakes that are contaminated with cyanobacteria, some of the toxins are actually making their way into the groundwater system. So people that have groundwater wells close enough to the lake are now finding that some of the toxins are ending up in the groundwater that are close to the wells from the groundwater being so close to the lake. So there's almost an exchange of the toxins. The toxins get dissolved into the groundwater and it gets taken up.
Once toxins get into surface water or groundwater, how is it possible to clean it up?
And again, another beautiful question. It is very, very difficult to remove the toxins from the water once it gets in. And it is very expensive to try to do it as well. You can use, at this point, activated carbon is one of the things you can use to get the toxins out. Activated carbon is very expensive. Right now, they're using ozone. It's another approach that they're using, but sometimes you still can't get all of it out. So your best approach is to try to prevent it from happening.
So with that being said, Byron, I have like 2 quick questions because I am on the edge of my seat right now. Aside from using carbon, or I guess the corporate cleanup methodology, what are some of the things that we as society community that we can possibly do in the event that we do have contamination occurring? And then I'll ask my other question if you have an answer for me.
Well, the first thing that if you approach a body of water and it is green, I would highly suggest that you don't get in it, you don't let your pets get in it, and you don't stick around it for too long. Especially if you see a lime green, almost paintish consistency kind of soup, pea soup type of consistency. You don't want to have any interaction with it. It would probably be best to report it to like the state or the county or city health department or something like that. Most likely they would have known and they would have put some signs there saying do not enter the water, etc., etc. But sometimes they can't be everywhere. That would be the first thing to do.
Gotcha. And if we're thinking like Caribbean specific, so you're from Dominica, we're from Trinidad, and I know we have a lot of Caribbean listeners. In the event of some contamination or suspecting contamination, is there anything we can do on our own which can help us or try to start some kind of mitigation of sorts?
Yeah, so the help we can provide starts before there is the contamination. By the time it's contaminated, it is no time to bring in the professionals. I mean, the things that you can do as a citizen is, there are a lot of things you can do. And it starts with, unfortunately or fortunately, it starts with the people that we elect to office, right? When you elect people to office that don't have a true understanding of what it takes to protect the environment, and they are more or less motivated by capital gains and profit, a lot of times they will sacrifice the protection of the environment for those profits. So there has to be a balance. And that is one of the important things we can do. There are things we can do at home as well. Like instead of opting for a concrete driveway, you can opt for a gravel driveway, because that allows the runoff from your home and from your yard and from your roof to penetrate into the soil. There's an opportunity for the soil microbes to break down any potential contaminants that are there before it gets into the groundwater system and contaminates it. When you have a concreted driveway, it just runs out down the street, it gets into the sewer system, and then it gets into your lakes without any real attenuation or any real opportunity to get rid of, like a nitrogen and phosphorus, the stuff that the algae likes. So there's stuff that you can do at home. You can use less fertilizer, you can use less pesticides, you can plant more native plants that are better suited for the type of soil and for the type of area that you're in. You can opt for using renewable energy. So there's a number of different things that we can do as citizens.
Byron, what amazing tips. I feel like we almost need to invite you back for another episode for us to talk about how we can and why we should stop altering surface runoff with like some of the construction we're doing and materials, especially within the Caribbean, right? Because one of the points you mentioned earlier, and we kind of touched on, like how we're being negatively impacted with climate change, and whether or not people want to agree or believe in climate change, just the thought of the fact that our ecosystem is changing and why we need to ensure we have a healthy and clean ecosystem, and how we really need to change some of our practices. So, no, this has been super fascinating. Kyron, anything to chime in? I'm fangirling a little bit over my friend here and the work that he's doing and the knowledge he's sharing with us.
Yeah, there was one thing actually. So you mentioned in that fantastic list of things that people can do, renewable energy as a way to combat water contamination. Can you just expand on that a little for us?
Yeah, sure. So, producing energy requires resources, requires, water. Solar energy, for example. Basically, when you use renewable energy, you're not relying so much on fossil fuels, which the production of fossil fuels is very harsh on natural resources. So by using renewable energy, you kind of reduce the amount of natural resources that you use, my natural resources we mean, water, for fracking, when you're doing your hydrofracking and all that stuff, you need to use water to make up those solutions, and then that frack material is sometimes reintroduced back into the groundwater system and potential for contamination, etc. So it's just a matter of trying to have a balance and figure out, okay, where can I, as an individual, make an impact in this bigger world that we're living in?
Byron, Dr. Winston, friend, such amazing thoughts, and what a great knowledge share. But we are not going to let you get away just yet because I mean, if you've been listening to these episodes, like you stated, you know that we always close off
right. Mm-hmm.
with a hot potato segment, right? Because we believe in balance on the Geo Trip. With the technical, we like to share a little bit of insight about our guests. So, welcome to Hot Potato. 5 questions where you give us the answer that comes to mind. I will let Dr. Prince take it away, and I will close up the rear.
All right, Hot Potato time. What was the last book that you read?
The last book I read might have been A Long Walk to Freedom, Nelson Mandela.
Excellent choice. All right. Middleham Falls or Trafalgar Falls?
Getting into some deep water there. Man, let's say Trafalgar because it's closer to get to.
All right.
From where I live.
You take that. Codfish sauce or sancocho?
Oh, jeez. Sauce.
Well, if it's sauce, then under the counter or craft beer?
Under the counter, definitely.
And if you've never been to Dominica, audience members, I am advising you, once you're over the age of 18, please go have someone take you to a neighborhood cabaret and ask for under the counter. And last but not least, can you close us out in some patois, or have you lost it? And that is all we need to end this.
Yep.
Audience, it's been a pleasure. This is Leika Welcome signing off another episode of the Geo Trip with our wonderful guest, Byron Winston, and my co-host and colleague, Dr. Kyron Prince. Guys, do you have anything you want to tell the audience before we...
No, I just want to say thank you for having me on, and hopefully I was able to provide a little bit of insight that's useful to the audience.
Again, thank you, Dr. Winston.
Thank you.